E dollar, please incorporate a dollar symbol. We'll understand what is the significance of this dollar symbol. Followed by that E producing T, bar E producing E plus T. So it is having two production rules merged together. And followed by that T producing I and T producing E. Okay. So this is one of the production rule we have considered. And now what we will do, we'll take the help of stack, as we have already discussed earlier, that yes, stack is playing a very important role. The primitive operations of stack, like the push and pop, which we are going to utilize in this particular example. Okay, so be careful and simultaneously do it in your notebook also. Do not simply just have a look on the presentation. Okay, so you need to do it yourself. So what I'm doing over here, we have kept three very important parameters. One is stack, another is tree, another is input. So obviously, what is expected at the end of the parsing is supposed to generate the full-fledged parse tree. So for that, we are keeping it as parse tree. Stack will be using as one of the containers for a temporary purpose for shifting the elements. So just like insertion and deletion, these are the two operations we are going to do. And we need to work with the input. Okay. So let me tell you the problem statement before starting this. The problem statement is for a given context-free grammar. All of you just make a note of the problem statement. For a given context-free grammar, after that you just mention the production rule as it is given over here. So for a given context-free grammar, please mention the context-free grammar. Parse the following input string. Parse the following input string. Okay, what is the input string? I plus I is basically the input string needs to be parsed with the help of this particular grammar given to you. Fine. So here we are doing it using a tree structure. Okay, so once you start working with the parsing process, what exactly we are doing? We are using two very important component data structure over here. One is stack, another is tree. So in first operation, what we have to do, shift and then followed by that reduce. So here we will learn that how to perform shift operation and how to perform the corresponding reduce operation. So in the first stage, what you have to do, you have to start with shift. We have to consider the first input symbol. As simple as that, we have to start with shift. So what we are doing over here, we have first shifted the I. Dollar is a symbol which is kept in the empty stack, and we keep on shifting the input starting from left towards right, one at a time in the stack. The moment you start shifting the symbol should be incorporated in the tree structure, because what I told you at the beginning, we are supposed to construct a parse tree at the end of the operation. Fine. So first input symbol we have already shifted from the input. We are having I plus I. So now in input you have only plus I because I is already shifted to the stack, and similarly we have start constructing the corresponding tree also. So which operation we have performed? We have performed one operation that is basically called a shift operation. Fine. So all of you please complete the same in your notebook also, understand and do it. And a lot of diagrams here you need to draw, so get familiar with that. Every stage you have to just depict the way it has been given in the slide, because these are all various stages associated with the parsing process. So you have started exploring the parsing process working behind the scene. So in the first stage, what we have done, we have started with shift. So let's move further. In the next stage, what is expected over here, we will have a look on the production rule. Now, while you are having a look at the production rule, every time once you have a symbol being shift it, we need to have a look on the production rule. Any specific reduce operation can we perform on that particular input or not? And here you have a production rule available called T reducing I. Correct? So we have performed the shift. Now what exactly we are doing? You start performing the reduce operation, and this is how we have done it. We are replacing I with T, as we have a production rule called T reducing I. So this is basically called reduce operation associated with the particular parser. Again, from the beginning, what we have done, we have taken one input stream with the help of stack. We have shifted the first element I. After shifting the first element I, immediately every shift should be followed by a reduce if applicable as per the availability of the production rule. So here also we have applied the same logic. Once we have performed the shift operation, immediately next to that, you start finding out what could be the production rule where I can be able to perform one reduce operation. And you got the production rule. The right production rule is obviously T reducing I, and you start replacing the I with the help of T. Okay, so first just follow the process, and later on we will analyze what we are doing. First we will complete the entire process, then we will go back and we will analyze that why we did like it. Okay, that what kind of operation we have performed and what exactly is the logic behind the operation. So basically we will analyze that part too. Fine. So have a look on the tree. Every time you need to update the tree and figure out the strategy being utilized to update the T. So now what I have done, I have taken the T as parent of I. Okay, so this is how we start constructing the tree. Just have a look on the construction of the tree because that part is a little bit complicated compared to the remaining part of this particular problem. Okay, the way the tree got constructed. Okay, so what operation we have performed? We have performed one shift and we have performed one reduce operation. Let's have a look what's next. Fine. So now what we will do, we'll proceed further with the same way, same strategy we will apply. So once you will start apply the same strategy, what's next? So now you start finding out that whether do you have another reduce operation available over here. We are simply checking it and we got it. Another reduce operation is E reducing T. So now we need to perform another reduce operation over here because as it is already available in the corresponding production rule. Okay, so this is how we have to proceed, and finally now we have understood that what is supposed to happen, that we are replacing T by E and we are updating the corresponding tree structure in the following way. Okay, so the same strategy being also applied in the last stage, and we have also done the same. All of you please update your notebook, is draw in the same way. Here every stage is very, very important. Do not skip any of the stage as given over here. Okay, please follow the strategy being utilized. You don't have to explain, you simply have to draw the diagram in the following way. Everything is self-explanatory, but obviously you need to write the rule you are using for performing the reduce operation. Isn't it? That's really very, very important. You need to refer the rule, the production rule you are taking to perform the corresponding reduce operation. That is really very, very important over here. Fine. So we have reached to one of the level of this particular problem set statement. Take your time and update your notebook. Please understand the strategy we are applying. So you are applying two very simple strategy. One is the shift operation. Another strategy we have also applied over here. That's basically called the reduce operation. Right. So now, if we proceed further, you might have understood the strategy that what needs to be done next. What we have to do over here, we again need to perform another operation that is basically called the corresponding shift operation we are performing over here, and plus being shift in the following way. Now here in this particular process, one question you may have that why we haven't considered S producing E, right? We have taken the reduced rule take E producing T. First we have taken T producing I, after that we have taken E producing T, but we haven't taken S producing E, isn't it? Before taking that, we have performed a shift operation. Okay, so in any specific shift reduce or sync strategy, once you start applying, just have a look on the context-free grammar and please make sure that you have understood four basic components of the context-free grammar. What are those components? One is V, T, E, and S. So while we are considering the set of production rule, we should not include the production rule which is having the starting symbol. Okay, so that is one of the very important strategy being utilized in any of the parsing technique. Even later on also you will get those kind of scenarios that we have reached till E producing T. So this is obviously one of the production rules, not the production rule which is having the starting symbol. Correct. So this is one of the most important strategy. Please keep this in mind while you are performing any particular type of parsing operation. Now here another very important part we need to take care while you are performing the next shift operation, how we are going to update the tree. That is another very important part. Till before it was very easy for you to understand that yes, I, the root of I is T, the parent of I is T, and the parent of T is E. That's well understood. But now, while you start shifting the class to the stack, what else to be done? So you have a symbol called E, and before that we have added class. Fine. So while you are adding the class over here, please understand that it is not coming on the same hierarchy of E. Fine. So that's why we have taken class as a separate intermediate leaf node. By the time we will be considering it as an intermediate leaf node only. Fine. And we have just kept it like that before making any further update. So now what do we have in the stack? You have class, you have E input. What you have in input, you have I. Fine. So what is our task? Our task is to complete all the input. We will not stop until and unless all input are consumed. Very important. And there should not be a single element available in stack. That's another very important condition needs to be fulfilled while you are performing any particular type of parsing operation. So far in shift reduce parsing, what exactly we are doing over here, we need to take care of all those parameters, whether all input being and whether all